Welcome to Unit 15 Micro Racer GT Level 1. This is going to be an extension of the previous Micro Racer. In that original Micro Racer, we just had the cars going around the track and wasn't doing a whole lot, and we had to manually switch the tracks, and there wasn't any other racer unless you made it a two-player game. Now we're kind of kicking it up a little bit, and we're actually having a artificial intelligence racer. And this is not some high-level artificial intelligence. This is kind of a low-level artificial intelligence, and the robot car is going to be following a set of directed turns based upon the track. So we're having to program the car to know exactly where to go. Let's check out what happens first when we do this. We also have some other things going on. Okay, so we have a start light. You'll notice the blue car, which I'm driving, has a bit of acceleration to it. So we added acceleration, and we also have the deceleration when it gets into the grass. And then when a car crosses the finish line, we have an announcer sprite that tells you who the winner is. And then it automatically switches to the next level, and we begin the race. Now you notice I have a third car out there. That's a car for a second player that wants to come in and play. However, I think it's programmed. Well, it doesn't really matter. What's important is that we know what's going on with that race car. Yeah, it's not officially programmed, but I could easily just attach a script and put a few other bells and whistles to make this thing fully operational. Okay, you probably noticed something going on. Let's start this again. The red car, let's watch this one. When it's moving forward, you'll notice it's saying something. It's saying 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, what we're doing is we're putting these signals to come out of the car by using the say block, so that way we know what turn it is on whenever we have to code this. And this helps us by knowing if there's an error on the screen whenever it's saying a certain number. And let me show you what an error would look like here in a second. Okay, so whenever it's saying a number, that tells you it's on that turn, and you can match it up with the code over here on the right. So when it says 1, okay, 1, 2, there's 2 right here, 3, okay, so it just went through these. Now it's going to say 4, then 5 and 6. It's those chunks of code, and we use a broadcast, or actually it scrolls down right here. Okay, so you can see that it's matching up with the pieces of code right here based upon what it's saying. So we're just setting a variable to a value and then telling it to say it right here. Okay, so second level, it's this large block right here, AI map 2. You can see I matched up with the variable right here. And you can follow along, say 5, 6, okay. Then we're down here. It should be 7, 8, or excuse me, 8 and 9, okay. Now here's a good example of when we need it the most. Okay, so we're watching it, it's 1, 2, 3, whoa, you see what happened there? On turn 3 it started going a little too far. Okay, now if I was wanting to solve this, and you're going to figure this one out on your own, I'm going to give you all the wrong coordinates, and this is kind of a learning lesson by convenience. I didn't plan on this, it just happened that way. And what happens is I switched the map. Okay, so I changed the map on here, and I deleted the original file, but I didn't update the coordinates for this map. And then when I started teaching it, I started thinking, I was like, oh, hey, I'll let the students figure this out, because I've set this little problem-solving technique here in action. It's like this is a good opportunity for them to go through and figure out how that works. So whenever AI map 3 starts, I can go through all the little details here and figure it out. And here's a quick way to problem solve on this one. Okay, so if I want this car to restart, I'm just going to double click right here. Whoops. Let me stop it real quick. Okay, I'm going to click on this one right here, and then I forgot this function. It will automatically restart it right here. Okay, so we're on the third map. We got a lot of errors going on. You can see that it's driving in the grass, and it's kind of making mistakes here on the different turns. Okay, and you can follow along with the numbers here to figure out where to make those adjustments. So it drives pretty good once it gets past the original turns of I think 3 through 6. Let's double check it again. So it runs 2, 3, not sharp enough, 4, a little bit too long, 5, and 6 looks pretty good. So based upon that, I know around 3 right here from 3 all the way down to 6. These coordinates and number of repeat loops for the turns here need to be adjusted based upon what I saw. So again, if it's running, I can match up with what turn it's on in the map and help isolate where in the code the error is taking place, so I can go in and adjust here. Okay, if I need to, I can increase the turn radius or decrease the number of steps. I can do a lot of different things. Whatever it is, I can make it adjust to match the track and make it look a little bit more fluid, like it did at the very beginning of the race, where it goes through the map here and just kind of, falls along with the track and makes it look like it knows what it's doing. Okay, so there's nothing revolutionary on this program. It's everything you've seen so far in every mini lesson. It's the original racing game. We're just making this AI racer. One of the big changes here is with the Racer 1, we allow it to accelerate, and we do that by setting a variable. Okay, we call that variable Racer 1 speed. Okay, and what we do is we'll change it by a particular value as long as it's less than 7 whenever the up arrow key is pressed. And then down here on this little blue box right here is where we take that value for Racer 1 speed and allow it to move those number of steps. And remember, when it's pressing up, that value is increasing. If I want to, I'm going to put Racer 1 speed up here, turn it on, and you can see it right here. I can turn, I'm going to hide that, I'm going to hide this, I'm going to hide this. Okay, so when I play it, you can see the value for the Racer 1 speed increase. It'll never get faster than 7, and I'd have to drive very well to, so, hey, that was pretty good, especially since I was looking at my microphone the whole time. Okay, so you can see that the speed never went above 7. That's because this value right here, or excuse me, this condition stops that from happening. Now here's something else I threw in the game just to make it interesting, add a little bit of realism, is your turn radius. And I set that to 3 with the variable, and you can see that we turn by the variable. However, to make things interesting, because that's what I do, is whenever the speed is above a particular amount or it's within a certain range, I actually, hold on, let me start over here. Let's focus on the turn radius. I'll get into this piece of code in a second. Okay, so the turn radius is adjusted right down here based upon speed. So the slower the speed, the greater the turn radius. And you can see I set the radius to 8 if the speed is less than 4. And then if it gets between 4.1 and 6, the speed or the radius is set to 6. And then if it's greater than 6, I set the radius to 4. I set the default of 3 just because, I don't know, that's just what I've done. But it doesn't really matter. You can change that value to whatever you want. And you can also adjust these as well. But the goal was to say that the faster the car was going, the harder it is to turn. Okay, now the speed right here, this is what I've done is whenever you are touching the track, which is right here, and I don't need this sprite, I should have deleted that. Okay, so anyhow, so whenever you're touching the track, which is, you've seen that before in the other racing game, is if the speed is above a certain amount, okay, you actually slow down greater when you're in the grass. Okay, so it decreases the value from your Racer 1 speed. So if you're going super fast, you'll notice that it decreases the value at a much greater rate, so you slow down much quicker, just because you have a greater speed. So if I really start going fast, okay, I try to give the user some momentum. So basically, if you're going super slow and you get into the grass, you don't lose a lot of visible speed. However, when you're going real fast, it slows you down at a much greater rate than it would if you're going slower, which is kind of realistic if you were driving a car out on the road. You know, the faster you go and you hit some dirt or grass, you're probably going to slow down just due to physics and all sorts of other stuff. Okay, I'll let you go through and read all the directions. They'll explain everything in detail. I'm trying to think of anything in particular. One thing to watch out for whenever you do program this is make sure you program in the order of the instructions due to the timing issues. I've seen sometimes people will do this and they program it out of order. They'll start with 1 particular area, like the start or finish or this or that, and the timing gets kind of messed up on the game. So make sure you program it in the order of the instructions, and you should not have any problems. And again, also on the last AI map right here, which I can give you that comment, AI map 3, you need to adjust the turning radiuses from I think like turn 3 to turn 6, somewhere in that range. You might want to make some adjustments so it actually stays on the track. All right, let's go back to the presentation here. All right, some terminology. Let's see. All right, went through the overview, what you're going to learn about. Some low-level artificial intelligence, acceleration, deceleration. Also some inertia when your car is going around the track, like I was talking about with the widening of the turn radius. Here's some details on artificial intelligence. It's a pretty big field. This doesn't necessarily apply to what we're doing here. However, it's good to know these background pieces of knowledge, especially as you move forward, because not everyone that learns how to program will be working in game design. You might be working in some other stuff, such as the field of robotics, voice recognition systems where you're talking to computers, the chat bot where you actually have a computer that's able to type back and forth with you, and navigation systems that can actually help you get around where you need to go. Very similar to a GPS, but a lot of navigation systems have a tremendous amount of errors in their calculations. So we're still working on those all the time as a collective technology society. Let's see what else. The AI in our code, like I told you, is low-level artificial intelligence. You might want to pause this and read through it just to reinforce what I've already talked about. I already talked about the up arrow and acceleration, and then the left and right arrow turning, so the increased turning radius as you go faster, and then the decelerating of the racer. Oh, I didn't talk about that. Okay, let's go back to the program so you can see that. Okie dokie, right here, the decelerating of the racer. This piece of code right here, okay, we're saying if you have to notice here that this if-else condition, which is all inside this forever loop down here. So in this if-else block, we say if it's touching track and racer speed is greater than 1.5, okay, this is going to tell it to slow down because it's actually touching the track. Down here in this else section, okay, we check this if this is not true, okay. So this by default gets selected if the first condition, and with this AND operator right here, is not true. We come down here. Then we say if the up arrow key is not pressed, see the not word right there, and racer 1 speed is greater than 0, then we reduce the racer 1 speed by -0.1. And what this does is it creates some deceleration. So when my car starts going faster, I take my finger off the up arrow, it comes to a nice little slow stop. You'll notice right here the calculation actually came out to a -0.075, and the car is kind of slowly inching backwards. I'm not really worried about that. I anticipate most people that play this game will keep the up arrow down all the time, and they're not going to get into a state where they actually have fun by watching the car go backwards 0.05. Okay, so I'm not worried about that, especially if they're playing this game to win the race. All right, and there you have it for Micro Racer GT Level 1. You'll program the stage. That's where all of our broadcast messages were located. And then you have these different sprites right here. Make sure you go through all the extension exercises for this. See if you can figure some stuff out. I'm sure I put it out there, but I would challenge you to see if you can intertwine some of the projectile lessons of making something fire and put that on your car so you can add a little bit of dimension of fun to this. Okay? All right, so good luck, and we'll see you in the next video.